everybody! It is my favorite day of the week. Tuesday's Hackster Café, and we're here this week with Huaishu, Peng, and Anup, Sathya, who are some amazing people who have worked on these. Okay, we'll get there, but these adorable little wearable robots that run around on tracks on your clothing. But first, your descriptions. Huaishu, you are an assistant professor of CS at the University of Maryland, and other things that are listed here as well. And Anup is an incoming PhD student at U Chicago, studying what exactly?
Computer science, but then I'm just gonna build stuff. So
Yes.
forget about the computer science.
Cool. So, I mean, the computer science can enable the other types of building.
Yeah,
Yes.
yeah. Mhm.
Cool.
It's just part of it, not all of it.
Yes. So, first up, you have this wonderful new project that I'm freaking out about called Calico. Could you tell us about it?
Yeah, sure. I mean, Anup is really the one who lead the entire things, but basically, what we're doing here is like we try to build a small gadget or small wearables that can sort of move around your body. And we really just like questioning this. It's like we have all this like smartwatch and wristband, necklace, and all these smart devices. But most of the time, like they have to stay at one place and one locations of your bodies. But when you do different motions and moves, that generate a lot of data, and we want to see what if this wearables does not just stay at one place. What if they can move around your bodies when it's needed? So that's where they started. I will stop here, but I don't feel free to chime in here.
Please.
Yeah, I think that's a good summary, but yeah, that's basically it.
Cool. Well, I have a bunch of questions. So, did you 3D print flexible filament onto the fabric? Is that what's going on here?
Ooh, okay, let's get into it.
Yes.
So that was one of the biggest problems that we had to solve. So it's actually just silicone. It's like molded silicone. So
Huh.
one of the problems that we had was that if you just have silicone, like the robot just goes through because it just pinches through the track and goes through because it's soft.
Ah.
So what we did was we 3D printed an inlay. I don't know if you can see the inlay. It's like a flexible inlay,
Whoa,
and then
cool.
we molded the silicone around that so that it stays within this, like the channel that we have here.
Uh-huh.
If that's visible, yeah. So it's a mixture of 3D printing and also it's like a silicone mold kind of thing.
That's really cool. So you get the
It's like a
flexibility and the durability.
yeah.
Wow. And those holes in there, are those for attaching it to the fabric? How do you attach the fabric?
Oh, it's actually just stitched on. I don't know if you can see
Ah.
it on here. It's just stitched on. But the holes here are actually for like small tiny magnets, like neodymium magnets. We have a
Ah.
Hall effect sensor at the bottom, so when the robot is moving along the track, you can see you like it detects the magnet and then it knows where it is.
That's brilliant. Are the magnets like, do they have any kind of encoding, or are they spaced differently so it can tell sort of which place it's in, or are they evenly spaced?
They are evenly spaced, but then what we did was so it knows the starting point, and then there's like a graph structure of
Of
how it's laid
course.
out on the body, so it just counts.
Right.
And yeah,
Dead reckoning kind of thing. And
yeah.
also, yeah, tell us what all kinds of sensors and things it have in here, because in this demo video, which is just mind-blowing, you're using it. This is sort of demonstrating the durability, but you have another part where it's used as an assistant for exercise, and it seems to be detecting positions of the body. So is there an accelerometer in there?
Yeah, we have an IMU on there, and we also have just a couple of GPIOs exposed so that you can attach any sensor onto it.
Cool.
And yeah.
How long have you been working on this?
Oh yeah.
Ooh. So I think I officially started spring 2020, something like that. But then it went on for a year, and then we went on to move to other things, and then we came back to it. And yeah, it's been a while, but I think like hands-on working maybe about a year.
Wow.
Right. So one of the challenges we ran into actually is like we sort of start this product in the middle of COVID, and
Yeah.
that was the time when the campus was shut down, and it's really hard to do this hands-on building experimental things. I think, and if I remember that correctly, one of the things we did is like we sort of disassemble it or live and then send it to the students' place if it's possible, so that they can build something at least at home. So it's like a long process, but I mean we made it through. So
Yeah.
At
Anup,
the
is
at
this
the
your? Oh, go on.
sorry, in the beginning of the pandemic, Huaishu was literally driving around dropping components off people's places because everything was getting delivered to his place, and yeah, it was fun.
Is there any kind of like hackerspace or makerspace at the university?
Yeah, so we have this lab space that I'm in right now, and also there's
Ah.
also a shared makerspace. They have some cooler stuff, and like we steal a lot of stuff from them once in a while. But but yeah, we have a couple of cool things here right now. I'm sure just before Huaishu joined, it wasn't that great, and I've heard a lot of people complaining about it. But right now, it's pretty good.
right.
Cool.
So the makerspace that Anup was mentioned is like it was actually inside this computer science building. So it's just like one floor above us. But campus-wise, we actually have, I think, more than 25 different type of makerspace now. We actually have a on-campus thing called Makerspace Initiative.
Oh.
We're trying to have this hands-on building type of space available to everyone. The sandbox that I've mentioned was actually in the CS building, but actually open to everyone, whoever sign the course and go through the trainings can just like knock door and get in and build stuff. So it's actually a pretty welcoming environment for makers. That's what we're trying to do here in Maryland.
That's wonderful. So, yeah. Oh, there's so much to dig into. Let me see where I should go next. Okay, so I actually have. This reminds me very much of an. Okay, I'll just go straight for it. This reminds me so much of this sort of, questionable practice where people bejewel these beetles and they wear them as living pets, but like attach to themselves and they can like crawl over their clothing, and I think it's called maquette, and but this is a much more humane version of that, obviously. But for me, it tickles that same idea of like, wow, you could just have a little robot that lives on you. Somehow, it just sounds amazing to me. What were your inspirations for this?
I think before that, I think one thing I just want to mention that I saw your videos with the owls like
Oh yes,
on your shoulders, and I think that's super cool.
thank
And
you.
I actually use that video in my class to motivate my students to think about different ways of doing wearables. Yeah, I just
Oh,
put that video yesterday because yesterday it's like the new semester starts on Monday, and yesterday was my first class. And for the overview, I showed the video.
of course, she was talking about Archimedes, which is going to come up with the robot
Yeah, that
familiar.
one.
But Archimedes is so basic, and Calico is so advanced. Like it's okay.
Right.
Words.
Yeah. Right. So we're talking about the like
So
where the
Inspiration.
idea is coming from, right?
Yeah.
So as I mentioned, the I think the initial idea was like I saw something with a zipper that can move around and that is motorized by small motors,
Oh, that's
and
cool.
that made me think about the mechanism itself. But then later, I'm thinking, look at all this gadget and smart things that people wear, and also rings and such, and wristband and earpieces. Um, I was just thinking like a lot of things doesn't have to be stay at one place.
Mm-hmm.
What if they can move around on your clothes or around your body? At that moment, we haven't really thought about whether it should be directly attached to your skins or clothes and such. But one general question we're approaching, we're poking there was, hey, wearables doesn't have to be stay at one place, and that's sort of the starting point of many of the explorations.
I like that you call it a railway that it can move around on here. And also that it's for locomotion. It's so good. Yeah, and you've got these tracks, but you've also got this little turntable inside in the system. so that it can go to different parts of your, because humans are branching animals. We have, you know, a central sort of highway and then these little this is a terrible metaphor, but yeah, and you can see it sort of moving around to different parts of the body on here, but also there's the turnstiles or roundabouts almost that it can use to move around. How tell us about the challenges that you ran into while designing these, because it seems like you've packed so much functionality into this.
Yeah, I think the turntable is literally the one thing that held us up the most.
Oh,
We literally got it working like one before the deadline that we were aiming for or something like that. But it went through a lot of iterations. So initially, the idea was that it's not kind of interesting to just have something that can go on one track. So we wanted to make sure that it can switch tracks. So we started with this idea of having like an electromagnet thing where it like swivels around and then attaches to it and then goes in, and then like we started toying with different ideas. I have some old prototypes here.
oh
um,
yes, please.
so this is like the first thing. So like this was the original idea where this kind of sits on top and then there's this gear and then it rotates. And
Mm-hmm.
then the idea was that we'd have another gear on the robot that like mechanically meshes to this and then rotates that, and then like it swivels around and then it can go in that
Oh,
direction.
so it rotates itself. Huh.
Yeah, but that whole mechanical meshing thing was, as you can imagine, it was a nightmare. Especially when it was moving, get it to stop and then mesh with the gear. That was a nightmare.
Right.
Um, so then, yeah, we had a couple of versions of that. So then we realized that the movement itself doesn't have to start from the like the like the motor doesn't have to be directly on the robot. So we moved to another one where we started with these like contact pads on the thing. Like this was
Mm-hmm.
supposed to be the top of the turntable. I think like it's something like that. So the robot attaches to the contact pad, and then there's a
Right.
motor on the thing which rotates it. Um, we had some other problems with that as well. So then, I don't know if you can see this. Like
Mm.
we were trying
Oh,
to make
cool. Yeah. Like
a like a
brushes.
yeah, exactly. Yeah. So we had pogo pins on the inside, and then that was touching the like the copper tape while it was rotating, so we
Uh-huh.
can maintain electrical contact while it was rotating.
Yeah.
So that was also another nightmare. So
I mean, theoretically, it's a good idea. It's just like
Implementation.
manufacturing
oh
and
yeah, yes.
implementation is always a challenge. It's especially if you just do like one shot small batch things.
Ooh. Right.
So this was another evolution of that where we had pogo pins at the bottom of the robot, and then like it then like attaches and then rotates around it. This is like a PCB that we milled on a milling machine, and then that was serving as
Oh
the
yeah.
base. Yeah, and then finally we settled on this mechanism. I don't know if that's visible.
Ah, is that a
Kind
little
of. Yeah,
DC motor you've got mounted sideways?
yeah.
Yes.
It's a DC motor with a worm gear, and then that rotates the whole thing.
Yeah.
So then on top we have these like contact pads, and then there are magnets at the bottom of the robot which just latch onto that, and
Mm.
then this rotates in the entire thing. Like this rotates. It's yeah.
Wow,
It's
how does it register that? Because DC motors are a little harder to make sure that they're in the right place, huh?
so
And
so
you're
on
mating
this one, if
tracks,
you
which
can
is
see,
amazing.
yeah, on this one you can see there's a magnet at the end of the track. So basically the track attaches at this end, and then we have another Hall effect sensor that detects basically when
Mm.
it lines up, and then once it's lined up it goes through.
Right. Ha, cool. I'm trying to find a good part of the video that's showing this. Just
So
Early on, I think it's just
beginning
like
of the
the
video.
aha,
first few shots. Yeah.
that's right. Oh yes, here we go. Haha. This is just mind-blowing to me. So all the power is coming from the robot itself,
Hmm.
and the turnstile is just
Yeah.
Right.
and
So
the way that these
yes.
magnets
So our initial idea is like as Anup was mentioned, we thought about having the turntables like turning itself and have the powers there, but then we think if the robot itself already have the powers, why not just use that part of the power to turn the turntable itself?
yeah.
Also make it slightly easier for the turntable to be I mean, it's not waterproof, but at least if you throw that into your washing machine, it's not that bad because you don't.
I was wondering about that. Yeah, because you wouldn't detach the tracks. Have you washed one of these?
Yeah, we did actually. We washed it and put it through a drying cycle, and it was fine. So
Nice.
the inside of it is actually PETG instead of PLA.
So it's
So
heat resistant.
yeah, it's a little more heat resistant than PLA.
Brilliant. Oh, there was another thing on the tip of my tongue. Let me see. Oh yeah, but so I imagine relocating the motors off of the robot also gave you a little bit more power longevity because it would be less heavy to move around. But what is the power longevity on this? How long can it run on this single battery?
So we have a 3.7 volt, like 150 milliamp hour battery. If it's constantly moving, it's about half an hour. But the idle draw on this is really long. So I think if it's just moving occasionally, it can go for a couple of hours. But
Cool.
yeah, constant movement, it's about 30 minutes.
That makes sense. But if it's hanging out on your back while you're doing squats or whatever, then it's not gonna suck as much power down.
The idle draw is like 8 microamps or something like that. So it's
Wow.
really low. Yeah.
Nice. What kinds of new technologies did you learn for this project? Really long list.
Where do I start? So basically, I didn't have any background in like mechanical design of any sort. Like even 3D printing was new for me when I started out. So just like getting that mental model of, oh, you design something and then printing that is not exactly how it turns out. There's like a gap there where you
Yeah.
need to figure out how it works in the 3D printer instead of how it just works in your mind. So I guess that was the biggest thing. Yeah, mechanical design in general. The we ended up using a really weird bootloader for this. It runs on JavaScript. Yeah, so that was interesting to figure out because I don't exactly remember how we landed on that, but coding like firmware on JavaScript was something new and like kind of interesting. Uh, what else?
And you also
This
coded an app for it. Like
yeah,
over here.
it's kind of a web interface, so it's not really an app.
Ah,
So it just connects through web Bluetooth, is what they call it.
smart.
Yeah.
Then you don't have to make a bunch of different native apps for it either.
Yeah.
What kind of microcontroller is actually inside here?
It's called an MDBT42Q or something like that. It's a BLE microcontroller. I don't know if you can see that. It's
Ooh.
quite small.
That's the unarrived thing. I think Alex would probably know this.
Focus. No, it's not focus. But
Cool.
yeah.
Let me, if you have you could also message me the name of it if you find it, and I'll try and pull it up here because I'm very curious.
Yes. I think.
How to message you? I was trying to figure out the here. Yes.
Excellent.
No. So this is the core. I think that's the Nordic.
Perfect.
Yeah, that's the microcontroller, and then this breakout module is like kind of what we use for this.
Good way. Oh, of course, yes.
Right. So I mean, this is really good. It's like it's really small, and it packed with BLE. I think also Wi-Fi as well, if I remember.
No, just BLE.
No, that's just BLE, but it's like very small, and it's very low power consumption. It's one of the main things we considered when we design this. We want to make things to be as small as possible. Otherwise, it's like have bulky things move around that doesn't really make a lot of sense. So I think we check a bunch of options there. ESP32 is one of the obvious one. I think we go through that. I mean, in the end, this is like very landed. I think the site is really certified for what we're trying to do. Yeah. Anup designed our own circuit board based on this.
So I don't remember now. Was the one that you were showing this one on the right, the smaller one with the castellated edges?
Yeah. I think the one on the left is what they sell. This website, the Arduino sells that as a breakout board, but this is what we use. But the best thing about the module on the right is that you just need to plug in power and ground, and it works. Wow. There's no operating circuit, which is so rare in a lot of these microcontrollers that it's pretty fun to work with. Nice.
Have you built any other projects with it?
we've used it on a couple of other things where actually we tried to solder this onto the board in the other project that we talked about, but
This one?
yeah,
We'll
we
get there
tried
in
to
a
solder
second.
one of these, yeah. um, but I don't think we've used any of this, anything else. Why should you remember anything else?
No, I mean this is our first time using this board, and we just sort of wrap up this project, so we haven't really started working on the next things. But I mean, this is like definitely something like we're going to put into our toolkit if we want to work on something that's small and low power consumptions.
Absolutely. So earlier, a second ago, you were talking about how it was an extra challenge because you were sort of doing things like small batch one-offs. Do you have any plans to take this and make it into more of a generalized design that you release somewhere? Or?
Yeah. So this, as you can see, this is kind of all the wires are exposed. It's kind of a not great for in the wild usage. So we have a sort of self-enclosed design that we're working on. I have some early shells where like the battery slots in, and the whole everything mounts together, fits together, and yeah, the all of the processes that we use to kind of make it is on the PDF of the paper.
Nice.
But we want to set up a web page maybe on Hackster.io with the open source board and a couple of other things.
Oh
But
yes.
I don't think it's there yet. We need a couple of more iterations before anyone can build it.
Right. So Anup and I talk about like making a dedicated page and also making this open source both hardware and software. But it's like documentation will take a lot of effort and also document to the level that everyone can sort of replicate.
Right.
Time. So
because there's already this PDF where people can sort of dig into a lot of the info. I meant to take a minute and look through here before we talked, but as it is, I just get to ask you all my questions, which is wonderful. But I'm looking forward to digging into this more later on.
Sure.
So good.
Yeah, I think one thing we're thinking about is like, if eventually we can get sort of a reliable toolkit, we can also just send it to people so people can try it themselves. I think that would be super cool. It's also a way for other people to explore the ideas of relocatable devices, right? You can attach it to a different sensor and see like what else you can do with that.
I love it. Also, I would love to build one of these, and you actually already did, the obvious thing that I would do, which would be to put a little. I love the googly eyes. That's amazing. I think we need more companion bots with googly eyes. Oh, yes! Did you?
Sorry, go ahead.
Did you name it at all?
No, we tried not to.
I mean, Calico is a cute name anyway.
Yeah, Calico was kind of a I don't know how we landed on that, but it was kind of a mixture of Calico is a kind of cotton, but it's also like a tiny cat that kind of climbs on you. So it's kind of fit well together.
I didn't realize it was also a kind of cotton. That's brilliant. I think that
this guy doesn't fit on the robot anymore because the robot had an upgrade with an LED, so the shell doesn't fit anymore.
Oh, well, we'll have to make a new one. I'm working on trying to make fuzzy bots. Actually, this is a really good fuzzy bot design because it looks like it's just sort of a 3D printed shell, and then you've attached the faux fur to the outside of it. I want to make sure that people get to see the rest of this video really quick, and we have one more question from the audience before we move on, which is, Elwood says driving around a baseball cap would be neat. I love that. Oh, two more questions actually. Okay, so yeah. Obviously, it's really cool that it goes on close. Have you tried it in any other applications? There's that one where near the start you sort of put it on your key holder, which I love. The track just magnets onto the key holder and then it gets stored by the door. Have you tried any other places to put these tracks?
We had actually we tried it on solid surfaces, but we noticed that when we do put it on a solid surface, the sag doesn't work very well. Like it tends to get stuck. But I'm sure that can be solved with a little bit of a little bit of more engineering on the track. I think I think for this one, we tried to focus on just staying on the body. We've also explored, there's a picture on the paper if you have it. We've also explored moving it from one person to another. We don't have that in the video, but it's just like we have magnets at the end, and then yeah, that's
I'm just gonna scroll through here because there's so much cool stuff in here that I'm sure by the time that we find it, we'll have seen lots of other neat things. Oh, a lot of this is actually in the video, which is cool. The key thing. It's so good. This magnet, it's really interesting to me that you say that it's actually easier for this to work on cloth than on hard surfaces, which is, usually kind of the opposite with electronics. And getting these tracks to mate up, it looks so effortless in the video. Whereas, like you were talking about with getting the gears to mate earlier, it seems like it's often quite difficult to get two separate pieces to mate up perfectly in order for a robot to work.
So
Yeah.
we have a magnet at the end of the track to
Mhm.
help with the meshing, and also we did go through a lot of iterations on the track to make sure like that the movement was smooth. So like for instance, I showed you the like we call it the infill. Like you can tell that this one is a little more spaced out,
Right.
but we've tried out a couple of more things where it was really dense, and this was like another magnet density thing that we tried with a lot of magnets to see how close
Whoa.
we can do it. So I think the density of the pattern mattered a lot in terms of making sure that it doesn't get stuck somewhere, or also just making sure that it goes through. And
Mm.
like coming back to the hard surfaces, I think the problem with the hard surface is that the bottom of the track kind of sticks with the hard surface, so
Right.
it's just the top half sagging. So when that happens, it
Oh.
tends to just get stuck. But then when it's cloth, the bottom also bends along with the thing. So, but yeah, that should be solvable. I think. I don't think that
Oh,
should
that
be.
makes sense.
Mhm.
Huh. Cool.
So I mean, I know showed you a bunch of like design iterations we have gone through for the tracks. We're still sort of iterating this because we recently had started new collaborations with some faculties in the art department, and we actually have
Cool.
collaborations with the dance professors. We're trying to put up a show that the robots sort of are moving around on the bodies of the dancers, and the control of the robots coming from the audience.
Oh, wow.
Like there's no video or photos for now, but that's something we're doing over the summers. And one thing we realized, like when you move in a really dramatic ways in a really fast motion, sometimes the track is not as reliable as we're thinking, especially if it's not attached to the clothes in a really firm ways. So we're trying to iterate the designs of the track right this moment and see how that can be attached to the dancer's clothes dressings in a better way. But yeah, so that's something we're trying to do right now. Is this product itself started as a research in the labs, but we're seeing all sort of different options.
That's so cool. I wasn't immediately able to find the graphic of transferring it between people, but Ginger is so right that like it would be great for contact improv between dancers.
Yes,
I
right.
think that figure is right next to the one with the key. It's just below that.
With the keys. Okay, well, I'll look for that. And in the meantime, we have this question from well, it's more of a comment, but like you could have a kinetic charging station that recharges during the wearer's movement. How do you recharge it? Have you built a little pod that it sits on, or you've built all these? For the turnstile, you built all these wonderful different ways that you could transfer power from the robot to the to turntable. There we go. But yeah, what about the other way? Do you have any novel ways of charging it?
The kinetic charging is really interesting. So what we had in mind was a wireless charging thing that goes in like the pocket of the hoodie or something like that. So when the robot goes into the pocket, it just wirelessly charges.
Right.
Uh, or it could also be in the environment. Like instead of putting it onto a key holder, you just put it onto a tiny charger of some sort. But kinetic charging is quite interesting. I'm not sure how much power you can generate from that, but that would be really cool.
Yeah, like sort of watches do.
Hmm.
Still failing at finding the person-to-person transfer, but There's a lot of other really cool stuff in here. I'm just amazed at how you were able to get all these. You demonstrate in the paper as well that there's an aesthetic component, of course, to clothing and anything that you're going to wear, and you've this is so cute. You got it so that it matches all these different. It can be dyed to match all these different fabrics. And I think it's a really important component of building wearable things that a lot of people don't think about when they're coming from the technical side.
I think that was one of our big considerations in the beginning. We wanted to make sure that it could ideally, at least the track system could kind of blend into the clothing, because the robot itself, it's whether it should blend in or stand out, kind of. Eventually, all of it is personal preference, right? But I think we've approached it directly straight from the onset as it should be as flexible as possible in terms of just what we can change and what we can do. But yeah, so because this was silicone, we could just dye the silicone and we could get any color we want.
So cool. And you already did a bunch of experiments with that. There's the video, and then there's also you knit it on like a pattern fabric. This is so cool. Leather, you got denim or pleather or whatever, sort of a felt material. All these different things you can attach it to. The sort of the name Calico kind of comes in again, where you're sort of blending multiple things together. Okay. I'm so disappointed I am late. Well, don't worry, Nalini. You can go and watch the recording immediately. So let's move on to this other project, because we're a little over halfway through and I want to make sure that we get to talk about it. So can you tell us about Fiberkit?
Anup?
Yeah, just...
Okay. Sure.
Actually,
so
is Zeyu in the live?
yeah, Zoyu's in the lab. Zoyu, do you want to jump in?
Oh,
Yeah.
a surprise mystery guest. Always lively. Hello.
No, you can.
I think they have no clue what's going on here. But so
Sorry, 1 second.
That's cool. We've got a cool comment from the audience that the robot idea is brilliant. It can be used in different applications like a personal robot pet and collect environmental data. And you were saying that there are GPIOs that you can connect arbitrary sensors to, right?
Right. Yes. So just like one of the things about Calicos, we actually run user studies with a bunch of users trying to perform dance moves with us, and also we send out surveys online and see people's perceptions about what they think about like having a robot around their body as what the potential usage people can would like to do. I think that would be something really interesting to see as well. I think that's part of the papers. If people are interested, you can check it out. I think one of the things people mention a lot is like using that for like remote diagnostics. If you cannot really see the doctor in person, people want to do body examinations with robots. So that's one of the things people comment a lot. But yes, so Zeyu is there.
Hey,
hi.
Welcome to the show.
Yeah, thank you. Thank you for inviting me.
Oh, absolutely. So we're going to talk about Fiberkit here. Is that how you say it?
Oh yeah. That's we decided to go with that name.
So kirigami is the Japanese art of cut paper, right?
Yes, it's been actually also widely researched in computational graphics and also HCI field, because it draw a lot of attention. Like a couple of years ago, when NASA came up with the origami like floating energy harvesting panel. I don't know what's the technical name of that, but then so people discovered that sometimes making a large scaled like 3D item is not really feasible. So they decided to see if there's a way to actually fold it together so it become like it'll become a really small configuration item, and then it can expand. So that's one of the coolest applications of kirigami and origami stuff used. So yeah, and here we're trying to explore how that concept can be applied to the circuit, especially like usually circuit boards are kind of used as a supplementary item that controls everything, but it's usually in a conventionally squared shape, and then it's constrained. So we're trying to see what if the circuit board itself can be the item body itself instead of being an add-on.
Yes.
So, yeah.
Right. So I guess like part of the reason for this product is like we do a bunch of things, like for example Calicos, and we need to design our own circuit, and oftentimes we have to send it out to outsource the entire manufacturing process, and that takes times.
Yeah.
We're thinking, like for 3D printing nowadays, you just have the printers in the labs, and it's pretty low cost. And you have 3D model generated design, and then send it to the printer, and can print that overnight or a couple of hours. And then we're wondering, is it possible that I can do the similar things for rapid prototyping of circuit, especially small flexible circuit that people do, like when you design small gadgets, right? I mean, there are, for example, we have the Bantam tools in the lab as well, like small.
Yeah.
It's really cool. But many of the things you can do with that, because it's used the drill bit, it's really hard to deal with flexible materials or flexible circuit. And
Makes sense.
This is really cool. And we're thinking, what if we can just make small circuit in the lab, but the circuit itself is also flexible. Doesn't have to be really rigid. So this is sort of the starting point of the entire products. And I think we show a bunch of things about how to, I think we do a bunch of experiment about the cutting power, and to understand what is the limit of using this fiber laser, which is really cool technology. Is different from the laser, the CO2 lasers. What sort of the limitations, the width of the trace we can generate with that. And then beyond that, we also try a bunch of things about, for example, using the laser to soldering components, to making drill holes, and also to fold the laser so that we can do the kirigami things, as you just mentioned. So this paper is really about exploring a new, well, it's not entirely new, but like new ways to making flexible circuit, relatively reliable, but also like affordable way. Right.
Yeah. So what is the base material here? You're etching the copper off of a base material, I'm assuming, so that you can create these, separated tracks and things.
Yes. So basically, ideally, you're supposed to be able to etch out a entire thickness of a material. But if I guess let's call it isolation area, where like it isolates the trace with the ground floor or other traces. So if the area is bigger, then you kind of have to manually get the material off after you have the contour. But
Makes sense.
yeah, so basically that's how the isolation areas are created between traces or pads. And then that's actually, the file is actually generated the same way as how conventionally we build PCBs from Eagle or some other equivalent software.
Uh-huh.
And then we parse it into like vector files that can be used in laser cutters.
Like a DXF
yeah.
or whatever it would be.
Yeah, DXF or SVG, yeah.
Cool. I love this roll assembly process. This is so cool. So instead of using fiberglass, like a rigid fiberglass layer, you're using Kapton tape?
Yeah, Kapton tape.
That's so cool. Oh, that's so cool. And it makes total sense. Like you could even do this without a roll or anything. You could, in theory, do it by hand, just like sticking the copper tape and the Kapton together. But then, of course, you wouldn't get a uniform layer, and that might mess with your circuit. Did you run into fabrication issues like that you had to solve?
Yes, in the beginning, like especially it depends on, because talk about we want to make it flexible and thin, so that basically, but the both material copper and Kapton has different mechanical property, right? And then they composite it into something that both the material property kind of contributes to the final circuit property. So if you want the Kapton to be really thin, so that the circuit is more plastic than flexible, then sometimes it's really hard to like get all the bubbles out when you're like trying to composite the two layers together. So that's why the plastic rollers are involved in some of the combinations in layer thicknesses.
Makes sense. And you mentioned that one of these is a functional Arduino. Is that this one that can work as an Arduino, or is it a different one?
Yeah, there are actually multiple one of these
cool.
that are functional exactly as an Arduino. So we're trying to use that Arduino-based circuit. Yeah, the ones that you're looking at are also functioning in the same way. So we're trying to use that basic functionality as a benchmark circuit to test out if our method is applicable for like just a regular circuit or like Kirigami circuit or flexible circuit, or are we able to do double layer or multi-layer? So yeah, that's how we initially started to testing it, and then we documented it in the paper the same way.
Man, this is so cool. And this is so small. Like, you can see from the quarter there, but this is like a CR1225 or something like that, or 1220.
1220 or something.
So small. I've used these exact battery holders, and they're quite good.
Yeah.
Have you actually applied these to? I mean, since a moment ago we were talking about the wearable robot, have you used any of these flexi materials on clothing at all, or looked into doing that?
We haven't really put the material directly onto cloth before, but then we have actually one of the applications is a earring, which is our first try on a wearable device, and then I think it does have a lot of potential on that because of the material property and also like how fast we can iterate on that.
Cool.
So I guess it kind of enables the designing of the wearables better as well.
I am such a fan of PCBs as earrings. It's like a huge part of what I do as well. Yes. Okay, so working with the fiber laser, we talked a second ago about how you're using it to cut out the traces and stuff, but it seems like you're also using it. So you're using it in so many different ways at once. You're using it to cut out the traces. You're using it to create sort of score lines for folding things. You're using it, I assume, to cut out the edge as well. Is that right?
Yes.
And then
we have something else, which is what you're showing on the screen. So we're trying to use the laser power to solder the components onto the traces that we make.
That is so cool.
Yeah. So the basic principle is that when the laser is working on the metal material, it's generating enough heat to flow the soldering paste, so that we can kind of like flow the soldering paste while the component is on there with the laser shining in, so that it'll cure onto the pads that we manufacture.
So do you do it all in one go? Do you put the solder paste on before? No, you probably wouldn't laser it with the components on there, obviously. So is it like a multipass thing? Can you take the thing out and then put it back in and have good enough registration that you can solder? Or do you have to place the components in while it's still in the laser, or what?
So it actually works both ways. So it depends on like what components you're working with. You probably won't want to laser batteries when the batteries is in the laser, but then for some like for example the chip and stuff, you can definitely leave the piece in the laser and then apply paste and then put the chip in the right place while it's still on the laser, and then so basically the laser cutting file are going to be parsed into like different sections. So for example, make the trace first, and
Right,
then
different layers or whatever.
you do some manual like manipulation with the solder and paste and the chips and whatever component you want to put on, and then you can start the next section which does the soldering for you. So basically it could be like a one go, or we also have some other mechanism. So basically we had like we used a hole puncher so that we can make holes onto the copper sheet that aligns with our jig on the laser, so that if you want to get it out and put it back again, you don't have to worry too much about alignment as well. So,
brilliant. And then you can use it as mounting holes as well.
Yep.
This is an amazing. Oh man, I'm so glad that at first I was really excited about the Calico Robot, but this is amazing. You're also using it to replace the silk screen because you can just etch in labels on here. I've destroyed it. I got too hungry for information. There we go. Wow. And my guess is that since it's so precise and you have such control over the temperature, maybe it's even better than soldering chips by hand in lots of cases, because you got to be careful about the heat transfer. Have you noticed any advantages there?
Go ahead.
So the part of this paper is just trying to understand if it's possible to really soldering things with lasers. I think for really reliable soldering, you're going to go through the temperature curves so that have the ovens to bake the components through the time of transfers.
Mm.
We haven't really done that part of the studies in this paper to understand the very detailed temperature changing curve or profiles yet. But I think that can be something we explore.
Cool.
But yeah, so the idea here is like for rapid prototyping, if you just really want to make a quick circuit in 5 minutes, let's say, and I think this is something that we're trying to do here.
Along with these sort of living hinge designs as well. It's really just sort of all in one. What is the specific fiber laser that you're using? If you can tell us.
It's just a laser that, like, if you search fiber laser on Amazon, you can
Okay, cool. Sort of generic one.
Right.
This is so amazing. Now we're at about 50 minutes, and we've got some questions here that I want to make sure we get to. But look at these gorgeous images. Everyone, go check this out. Oh, here's an earring. Okay, settle down, Alex. Focus. We have a couple questions about the Smart Lab. Would you be down to talk about that? We've got a question from Ginger. What are the Smart Lab students' backgrounds? EE, CS, both, all of the above? Or?
I mean, Zeyu's background. I mean, he can talk about this himself. He has a Mackie background, I think, as undergrad, and then a little bit of EE as well. Anup, I think that's EE, right? I mean, you have a design / EE kind of things. I don't know what it's called, but it's like a mix of the EE and design program from the undergrad.
Brilliant.
And then he joined UMD for a master in HCI, so doing human-computer interactions. We also have lab mates in the lab with EE background and CS background. So I would say like human-computer interactions or the things we do here in the lab really require like interdisciplinary background. So
it sounds like an amazing place.
You know a little bit of everything. But if you come with one background, it's cool. It's totally fine. It's like we get to learn through the process.
Lots of cool work going on in terms of democratizing different types of fabrication and stuff. Interactive hydraulic devices with just an affordable SLA 3D printer, plus your work with the fiber laser, just like using one machine to do kind of all parts of the process. Super cool. We have a question from Nalini as well. Do we get a lab tour? Would you be down to show us a quick view around your lab? Or I know that, you know, my camera is pointed in a very specific direction so that none of all of that horribleness is shown, but maybe if it's an actual lab, it's like actually tourable. Would you be down? You don't have to say yes, but you could.
I mean, I don't really know, so I will defer this to Anup and Zeyu.
Yeah.
We can kind of show the lab, but it's kind of messy-ish because a lot of projects are going on. But
that is, you know, I never trust an engineer with an organized or a clean space. So, you know, tidy. Let's put it that way.
Okay. Then we can maybe just turn the camera around and see.
I'm so excited.
What they're saying, so you need.
Oh, I see. So yeah, people want a lab tour, and let's just turn the camera around. And
Absolutely.
So actually, we can start from here. So this is the electronic prototyping bench, and then so this is where all the electronic works are done. We have like basic stuff like soldering irons, heat gun, components, and some diagnostic devices. And then yeah, so this is a lot of mess, I guess. But yeah, that's you mostly find whatever is useful for electronics here. And then so on the other side of the lab, we have a lot of stuff. Okay, we have beanbags for relaxing, but
yeah, and
so
for maybe those late lab nights.
Yeah, so on your left hand side is a corner for fabrication. I mean, part of it. So basically, you can see the automaker there, and then our lab mate is working there.
Hey.
So the green thing behind him is a CO2 laser.
Ah.
And then and then on the desk that you can see a monitor light up. That's where I was sitting just now, and I'm working on a printer. There's an Ender 3. You can see that it's actually moving around.
Oh yeah. Is
And
that a
yeah,
mini drill press on the counter?
that's actually like a liquid extrusion nozzle.
Whoa!
So we're trying to do some experimental research on the next project. We're trying to print some magnetic activated display.
Cool.
So, and then actually behind that is the laser source for the fiber laser.
Hmm.
And yeah, and then you can see the drill press on your right hand side, and also a small wet lab ish space where we deal with some materials. And then on the right hand side of that on the table, you can see a white box with orange shades. That's where all the resin printers are. So we built that too, so that we don't have to take out the shade for every single printer if we want to
Smart.
watch and stuff. Yeah. So and then the rest are really just a shared space for people to sit on. And there's actually there's a robotic arm. I don't know if you can see
Oh
it.
yeah.
Yeah, that's a open source robotic arm. It's like a maker version of the big 60OF robotic arm that Huaishu got for us for for experiments.
Very
And
nice.
then yeah, so the rest are there's a 2 card, but yeah, a lot of things are happening, so it's kind of messy, but yeah, that's kind of
That just means that it's being used. It's a bonus.
yeah.
Amazing. Thank you
Cool.
for the tour.
Yeah, no problem.
So that was wonderful. This place seems like such a wonderful land. Before we wrap up, I would love to see this video that Huaishu has queued up here. Would you like to tell us what this video is and give us a quick look before we wrap up?
Yeah, sure. Actually, yeah, just trying to learn the interface. But,
Wow. Oh, it's a whole demo video. Excellent.
yes, it's a whole demo video.
So there's the Kapton tape and copper going together. Yes, the roller. Is this designed for, what is this roller designed for? Is it for,
Very high end.
and these are the holes for registration? I'm just enchanted with this process. And it's so fast.
Yeah.
Reading is always a challenge. Nicely done. And that's just a Atmega 128 or 328 chip on there? Wow. What app is this here?
So this is actually a user interface designed by our collaborators from George Mason. It simulates the folding angles that the 3D model is folded. So it's slightly mounted folds at different times.
Okay, let me turn down the volume on the video really quick. I'm so sorry. I asked you a question while we...
Alright, so what I was saying is like the interface is designed by our collaborators from George Mason's. So basically that can give people a simulations of how the shapes folded into, so that you can see, or at least you can have a sense of how the things will look like after it's fabricated.
Cool.
Right, and also as you said, it's like the folding and also cutting is actually pretty fast. You can
It's
see
so
right.
magical.
Yeah.
Oh, wow.
And it's like because you can do the entire things by yourselves, so it's like you can combine the functionalities of the touchings and the forms with the electronic things.
This reminds me a little bit of Calbourget's work. Have you seen that with his PCB actuation?
Yeah, right. I
Yeah.
think right. I think it's the sort of the end of the videos.
So cool. Oh, wow. This is just everything you folks are working on is so stunning. I wish, well, someday we'll have you on again. Maybe someday we'll meet in person. Maybe I'll come someday to the Smart Lab and get a tour. It would be so cool. It
Yes.
seems like an amazing wonderland to build stuff in. Yeah. Thank you folks so much for joining us.
Yeah, sure.
And
And thank you for having us. It's
oh, yeah.
really, I guess it's also a good opportunity for us to introduce our products to the community. And as we said, we want to make this open source. So once we
Yes.
have some good documentations, we're going to send it through Hacksters.
Here we go. Yes, please. We would love to have you on Hackster. In the meantime, folks, you can look at some of these publications on the Smart Labs site, which I believe I've linked below. If not, I will put it there. Also, you can look at Huaishu's website and Anup's website, both of which, I love that you made this cursor thing, but it kind of like bothers me. Like I want to be able to shake it off. But two good websites. As with many of us, it sounds like maybe the websites are not the most up-to-date places. And where should we follow you to stay up to date with what you're doing? Hackster, obviously, once we get you set up. But
I am not on any form of social media, unfortunately. So
congratulations, you're free.
The small smoke signals out to get in touch with me, but
Okay,
email is always good. It's on my website.
excellent,
Right. So I think our live website is pretty up to date.
perfect.
I have a Twitter account. I haven't really tweeted for quite a while, but I guess I'm going to tweet something soon. So you should be able to find me on Twitter as well. Just
Oh,
search.
we'll tag you in our posts about the show on Twitter. And so, folks, you can either go and follow Huaishu directly or go check out the Hackster Twitter, and which is, I was at a conference this weekend, and someone, of course, said Hackster.io. It's Hackster.io. But we are, of course, tweeting about this event, and we'll put a link there and tag you. And then, of course, as always, click the links in the description below. We've got these websites. We've got the Smart Lab website, which is, as why she said, actually up to date, amazing in this day and age. And thank you all for watching. Thank you to all of our guests, including our surprise guest. And yeah, have an awesome, wonderful rest of your day.
You too. Thank you so much.
All right, hack on. Ciao.